So how do we store this data on a web server? We already know how to store text files when we're running on our local computer. We know how to read and write text files. Could we use this kind of text files on a web server? Well, we could, but we're going to see in a minute that actually wouldn't work too well. It's not a really good way to scale up, and it's very, very inefficient. To make this a little bit more concrete, let's make an example kind of data system that we might want to store on a web server, and then we'll talk about how that might work and what its requirements might be. Well, personally, I like to exercise, and I use a website called Runkeeper to keep a list of my exercise, right? And a lot of people do things like this. You can get a list of what you've done, and so I've got a list of all my running, and I can get a list of each of my activities. So this is when I've gone running. You can see it goes back a long time. Actually, it goes back for several years, and then I can generate various reports and see how much I've been running. See, I've done a decent amount of running over the last 6 months, but I didn't do too much last winter. I'm going to see if I can do better this winter. So we're not going to worry about all the details in this kind of website, but suppose that we wanted to do the basics of that. That is, we wanted to implement a website that enabled us to have a list of users, where users might have some information, like here, let's just write down what we might have. Maybe we'll have runners, and each runner might have their name, maybe their email address, maybe their picture, right? Some basic profile information. And each runner would have a bunch of activities. And activities might contain things like what kind of activity, or suppose we were just doing running activities for now to start. We might have something very simple, like how long the run was, its duration, its distance, maybe what time of day it was. Maybe the date is more useful. So the idea is you would have lots of runners, and then for each runner you would have a lot of activities. So how would you store this? Well, we could store this in JSON and put it in a text file, right? Maybe you could have one super gigantic file that would store all of the data for all of your runners and all their activities. But think about how that would work. Every time your web server responded to a request, to display a web page, it would have to access data about a runner. It would have to load in that entire file and parse that file, right? Search it to find the elements you want, and then finally it could present the information that it found. Right? That would be outrageously expensive. Computationally expensive. Imagine you had 1 million people, right? That would just be, you'd be having to load all 1 million people's data every time anybody requested anything. So that's no good. It would make more sense at least to break this up so you could store one person's activity and then only load that person's activity when you needed it. So you could have one text file per runner. Well, you actually could do that, and you could have a mechanism where you would decide what the name of the file was, and you would just load that file. The problem is, remember when we did our own text processing of files? You actually have to read in the text and parse it, right? Turn it from a string of characters into structured data. And that's actually also a fairly computationally expensive task. And it's expensive to read, and it takes a longer time to read and write text files. So we could do that, but it's just not very scalable. So instead what we want is a more structured way and a more efficient way of storing this kind of information so that we can scale it up to a really big successful site, right, with millions of users, dozens and dozens of, maybe hundreds of people asking for data per second, right? You're making tons of money with your website, and we want to do this. Well, there's two parts to this. The first is we have to think about how we want to structure the data to make it very, very clear exactly what the elements are, figure out what kind of queries we want to be able to make against the data so we can efficiently ask for particular kinds of data, how we're going to store it, what the data types are. And then we need some kind of technical mechanism to implement that efficiently. Let's start by talking about the first thing, which is how do we just structure the data in a nice, clean, and simple manner? Well, before we get to the final answer, which is going to be to use a database, let's look at how people often do this themselves if they want to just have a little bit of structure to their data. And that is, they use a spreadsheet. I've got here Google Docs, but you can use any spreadsheet you want. And you can imagine that we create a sheet for each runner in the system. Maybe I'll even rename it, and I'll call this runners. And then what I might do is define the first row to be a header saying what kind of data we have. Well, maybe we're going to have a name, the same kind of things I just talked about. We'll have a name, an email address, and maybe a URL of picture. In practice you would have more stuff, but that certainly gives you the basics. And then we might even say we'll bold this or something to make it clear that this is really the headers. Then for each person in the system you would put in another row. So here's my name, my email address, and maybe I've got some picture on the web someplace. I won't worry about it exactly what the picture really is, right? And then you might have another user, right? Maybe Talk or TA, and he has an email address. I'm not going to put down his real email address, and the URL of his picture, blah 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 blah, right? Whatever it is. The point is, this is a way to structure this data. We've defined that this is a table of runners. We've defined what the fields or columns are, and now we put one row for each runner. Now let's talk about their activities. So what we're going to do is we're going to add a new sheet, and I'll rename this to activities. And again, we will do the same kind of thing. We'll set up a header. Here, let me make this big so we can see this, read this well. So just like we were defining when we were building this, first thinking about this data, we will have duration, distance, and date. And now we can go ahead and fill this in, right? Maybe, actually I ran this morning with my daughter. She ran a first 5K race with the girls on the run. It was really fun. And we ran it in 37 minutes and 38 seconds. It was 3.1 miles, and we did it today on November 17th, 2013. Here, let's bold this. Yesterday I ran with my friends. We ran, I don't remember exactly how fast it was, but it was about 60 minutes, probably a little bit more, and it was about 7 miles. That was yesterday. And again, you can see we start putting these things in. Now, suppose Talk ran. He's probably a really good runner. Actually, I don't know, but maybe he ran 9 miles. And he did that yesterday also. We immediately see we've got a problem here, right? Because how do we know which activity is whose? So what we need to do is a way to link or join these two tables so that we can say one of these rows of the activities goes along with one of these rows in the runners. So the way we often do that is we add an ID, and this is kind of a unique ID. So maybe Ben is ID 1 and Talk is ID 2. Then we can go to our activities, add a matching ID column, and we'll say these first two runs were associated with ID 1 and this other one was associated with ID 2. And this gives us all of the data we need so that we can easily create this stuff and manage it and query it. So I could get a list of all of the activities, I could get a list of all the runners, or I could get a list of just the activities for a runner. For example, we could say, well, when Ben Peterson logs in, asks for his ID, it's number 1, then go to the activities and do a query and say, give me all of the rows where the ID equals 1. And then that will give me just these 2 rows, and I can use that data. And that's the basic structure that we want to support.